This is TWiT.
It really kind of seems to, in my view, stem from this idea that, taking Bitcoin as one example, Bitcoin has a large ecological kind of toll on just managing Bitcoin behind the scenes. And Chia seems to aim to hope to address that a little bit. And, it has kind of a green perspective.
Yeah. So one of the goals of Chia is being much less wasteful, greener than Bitcoin is. That doesn't, in terms of Bitcoin's day-to-day functioning, that doesn't cause a problem for Bitcoin's running. It's gross and it's bad for the world, but it doesn't make Bitcoin run badly. Although related to it is Bitcoin's whole point is that it's decentralized, but it's not as decentralized as you'd really like it to be. So I came up with this whole grand plan for a new consensus algorithm that's much greener and more decentralized than the one in Bitcoin is.
And that's using space versus
it's using
computing power in order to
So Bitcoin is based off this wonderful, horrible idea. Bitcoin is a secure distributed database. Now, that sounds like an oxymoron. How can you have a secure distributed database? How can it be that if everyone just leaves and totally new people come in, the database continues moving forward without interruption? Because don't you need like a quorum of people in order to keep doing things? And the idea in Bitcoin is that you have this blockchain that it requires actual computational work to create. So you have the technical term is deadbeefs, but you have in order to make something that looks like a blockchain, there's work. The actual electricity, basically when you have a Bitcoin mining operation, all those computers burning all that electricity, they're not actually doing anything. Most of what they're doing accomplishes nothing. What they are doing is they're printing lottery tickets.
Right.
Once in a while, one of them prints a winning lottery ticket. Like once every couple of minutes, somewhere on planet Earth, one of these machines prints a winning lottery ticket, and then everything moves forward. And what this accomplishes is that if you and I are just reading this database and we get into an argument about what is the current state of the database, we can resolve this argument just by looking at the weight of our blockchains, and whichever one had more blood, sweat, and tears go into its creation is the winner. And this allows for very rapid, very reliable consensus on what the current state of this database is. And this is a really amazing idea. It really accomplishes this seemingly impossible task of making a secure distributed database. Now, it has a replication strategy of everything goes everywhere. It's in order to make it possible to keep up, it has this limit of only really handling a few transactions per second.
Right.
And you have warehouses full of computers burning electricity doing nothing. But those caveats aside, it's really accomplishing something amazing. Yeah. And it's hard to figure out how to improve on this. And people go, well, we'll just use a different mining algorithm, just a different way of printing lottery tickets. But those all kind of wind up being the same. When you mess with it, what winds up happening is the way you mine Bitcoin, the way you mine any cryptocurrency that's truly distributed, that really does have a blockchain, that boils down to you manufacture custom hardware for doing your mining, and then you burn electricity with that custom hardware to do your mining. And that's what it all boils down to. And you can, if you're really clever, you can mess with the balance between the electricity and the cost of the hardware. You can make the costs of doing the design and fabrication of the hardware more or less. And usually people try and make it more, and that turns out to be a bad idea because that's also a source of centralization. You don't want it to be that someone who spends a ridiculous budget on designing better hardware now has much better hardware than anybody else, and if anyone else wants to compete, they have to sink so much money into it, no one's going to do it, and then you only have one vendor of the hardware. But almost no matter how you play games with this, you're going to have waste directly in proportion to the amount of rewards that are being handed out by the system for doing this mining. And that's very hard to get away from, because you do fundamentally have some resources getting consumed in order to move the blockchain forward. And if you don't, then you can't have consensus come out of it. And if you want to get around this, threading the needle on this, what you need to do to avoid it is let's find some resource that people have already wasted money on, that people have over-provisioned, and make it so that people can utilize that at no additional cost in order to do the mining, or the equivalent of mining operation. And actually, Satoshi, who created Bitcoin, he thought, or at least hoped, that Bitcoin would kind of be like this, that the cost of Bitcoin mining would mostly be the sunk cost of having bought CPUs, and that the cost of electricity would be relatively small by comparison. Now, it hasn't worked out that way at all.
No.
Custom CPUs are orders of magnitude better at mining than general purpose ones are, or custom chips are orders of magnitude better at mining than general purpose CPUs are. And
there was a time when
no. As soon as there was any custom hardware at all, it obliterated the general purpose CPUs.
It kind of eliminated that option.
Yeah. And then the costs of the electricity are huge as well. So you have these two big sources of centralization around who it is that's manufacturing the hardware and where the cheap power is. And so Bitcoin, a handful of entities could hijack all of Bitcoin if they wanted to.
Right.
And that's not a good thing. So in terms of where's the loophole here? How can we, this is all loopholes and loopholes. It's
sure.
right. Well, you can't have a secure distributed database, but there's this loophole. If you do this one thing involving computational complexity, it's then we want to make it less wasteful. So let's find the loophole to a lot of threading the needle here. But it turns out there's one resource that kind of works, which is storage capacity, right? Unlike CPUs, storage is all the same thing. Bits are bits. There's no there aren't hard drives that are specialized for different things.
A smarter hard drive or whatever.
Yeah,
you have space, and on that space you can store bits of data.
Yeah, and that's it. Yeah. That's all you got.
Right.
So if you can figure out a way of some algorithm for proving that you've used space with where you can prove the amount of space that you've used, and it doesn't require really much of any electricity to do that, and can do that with very low latency, because you can always do it with high latency because you can regenerate your work, right?
Sure.
Then maybe you can do something here. And so this is called proof of space as a general concept, and a few people have worked on it. There was an academic project called Spacemint, which actually the advisor on that is a really important advisor to my company. He's my co-author on our green paper. And there's a lot of just very technical problems with getting this to work right. You have this problem that you didn't make it cost anything you intentionally made it not cost anything to do these lookups. So now you have these just grinding attacks. Someone can go, oh, well, I'm just going to generate 10,000 versions of the history and pick the one that works out best for me. And now you're back to someone with more CPU being able to get ahead. You need to have a system where not only don't you need CPU to farm it, but you can't use CPU to farm it. And people are clever, and CPUs can do a lot of things. So it's a question of how do you stop people from doing that. So
people will always be looking for the way to take advantage of that too.
Yeah. So
you might have it figured out at one point. At another point,
all right. So, but there are real computer science things you can do. So I came up with this grand scheme of let's mix together proofs of space and proofs of time. right? Because the proof of space can look stuff up at low latency, and the way you show that it was done at low latency is you pair it with a proof of time that comes after. So the combination of those needs to take a while, but it's not using up a lot of electricity. It's kind of like, instead of everyone in parallel burning electricity until they come up with a winning lottery ticket, everyone looks up in advance using the proof of space who's going to win in the end.
Right.
And then you sit around waiting for the proof of time to be done on that one.
Sure.
And then that tells you the next block, and you move forward from there. So there's a lot of much more subtle technical things there. And the green paper that we just released is really all about this. It's like, how do you take proof of space and make a secure Nakamoto consensus out of it? And the whole thing there is about, well, you're going to have proof of space and add in proofs of time, or verifiable delay functions is the technical term for them. And here are the types of attacks you can have. Here's how you stitch everything together, and how you do work difficulty resets and all that kind of stuff. And it makes reference to these other two very mathematical primitives you need at this point, which are the proofs of space and the proofs of time. And so our green paper is actually quite accessible, and it's kind of a fun, it has fun math in it. It's like an accessible thing you can work your way through, and really motivates everything. Where our other materials are on the proofs of space and time themselves. So we've had our VDFs out for a while now. We just finished our second VDF implementation competition.
Right.
And we gave out over $100,000 in the first one. We're going to give out $100,000 for the second one as well. Not quite announcing the winners of that one yet. But we also, when we released the green paper, we, along with it, released our proof of space construction. That one's, which is based off some pretty serious computer science research in a paper that was in Asia Crypt that me and Christopher co-authors on, and the actual construction has a lot of the details that you need just beyond the core idea really fleshed out in it. And we're doing another implementation competition for that one, which is another $100,000 in prizes. So I encourage everyone to please come look at this, especially if you're a programmer and you think you're smart. That's open to the public, and the winners will be selected just by whoever's implementation runs best on our benchmark hardware. So really very fair competition. But those two primitives have a lot of like very, very technical stuff hidden behind them. But in the green paper, it just says, well, we'll just assume that those are done. Just treat them as black boxes. And then these other projects on these other things.